Hi, and welcome to another Rigonomicon.com video. Today we're going to be talking about eyeballs and how to rig them and animate them and get them up and running inside an engine. From the start, who is this video for? If you're someone from the movie industry and you see this and you're thinking, oh, I don't need to know this, actually you might want to rethink that strategy because with things like what's been going on at Disney, where they replaced their green screens with real-time Unreal backgrounds. This is a skill that might actually help you out, and also understanding how a game engine works, so that you can get something that looks good into it. Is a valuable skill to have, I think. Unless, of course, you already know how to do all this stuff. If you're a video game person, obviously this could be interesting for you, and I am providing the tools that I'm going to be using here, including this project with the eyeball. Please look at the description and you'll see where you can download it. I'm also going to be providing Maya files, so you can grab what I've done there as well, because it'll make it easier to bridge the gap between the two softwares. For those of you also that are looking at this from the perspective of, I want to be able to animate something that is from like maybe an anime character, here's the same shader but with an anime look. So if you have like ink and paint type of stuff and you are creating eyes with this shader, you can use this to give life to your characters in a way where their eyes don't look like painted eggs or little ping pong balls with paint on them, by having a little bit of depth that also responds to light in some way. Remember, this is meant for a anime or a cartoon shader, so it still works well with that kind of a setup. So with that in mind, we are going to just take a quick look at what we have here. So the first thing I'm going to do is I'm going to look at this one over here, and just like we did in the other video, we saw that they'd had depth, right? It had some sort of a optic or refraction. The index of refraction of our eye is 1.37. So keep in mind that that kind of material would refract the image underneath it. That's what gives us. It's funny because it gives us the feeling that these things are curved, but in reality, the iris is actually quite flat, with a bit of a bevel. So I remember I spoke to a number of modelers in the past, and they were like, well, why can't we just model it and then put something reflective on top? And I was like, well, first of all, we'd have to deal with transparencies. It's always best to just deal with it all in one, to not have any issues with that. You'll notice also, as I pass over with this shader, you'll notice that there's that nice effect of the cornea with the reflection. And even though this is a pure sphere, this is just a sphere, but we can fake a lot of things, and we're giving the sense that there's depth. In the case of this one over here, it's a little bit different than the other ones, because this is technically a sphere, yes, but we're mapping it spherically, whereas this method is designed to be a planar projection in the front to get a nice clean cut circle. And also, everything has been calculated, like the refraction is meant to be affecting, depending on angles relative to a planar projection on top of a 3D spherical, like vertex positioning. So in the case of this guy, it's going to look a little different. It's not going to be as clean. It's not going to be a clean circle, because we're using, in this case, it's the Unreal sphere. And actually I tried it with the Maya spheres as well, the one that has a single wrap that goes all the way around, and it's actually worse. So the Unreal sphere is about as good as it gets for this kind of thing, but you still see like there'd have to be some work here to make this more round, whereas you don't get that problem with one that has a planar projection on the front. The only thing this is interesting though, just to show you just how accurate it is, by making it a spherical UV on a spherical object, which is counter to the calculation of what we're doing here for refraction. We can do this kind of thing. Let's see, where's the depth scale? So if I move that in, Like you have to remember that this is just a sphere, but we're compensating based on its some materials or some textures that we're storing that have information on how the image is going to warp depending on the camera's angle, right? And that is something that's very interesting, because this looks like it's an object inside a sphere, and it's just a texture UV offset. Just to show you that one, it's not really all that useful to us right now, but at least it proves a point about what we're actually looking at. And over here, there's a lot of options. I made it so that you can change the colors of the eyes very easily. So if I go over here, and right now this is a window that I have halfway in, so I can see all the parameters for it. So you can change the color very easily. You can make the I made it so that it has multiple levels of like if I go over here and I zoom in, you can see that I can change the color very easily, and it's got multiple types of colors. So for example, the texture itself, if we look at the texture real quick, I'm going to turn that on and I bring this out, you're going to see that this texture is basically a texture that has 3 layers of, so if I just look at the red, let me just get rid of this and go to red. This is the red channel. I'm not using a texture in the traditional sense. I'm using it as 3 different masks. The R, G, and B combined together does not create an image. It actually is 3 separate channels that are being used independently to create the color and combinations that I want to have. So if I go to the green, here we have more of that star pattern and more of these veins type of thing, and we can control how strong this effect is and so on. And then for the blue channel, I used it as a, can't see it very well here, but because it's set to no sRGB or linear, and it's got this gradient ramp basically that we can use to create kind of like this offset color. And because we have these 3, we can do a couple of things with it, like I showed you. So you have a lot of control over the color, but the most important thing that we need to look at here is there is a value. One out of all of these things that I've put together here. Oh, and one thing I need to make a shout out here. This is not something I wrote myself entirely. I've done a lot of work on top of it to get it to be useful, like the normal map and everything for how the light bends around it and so on, to give us that corny effect. But there's a lot of stuff in here that, like the core, the fundamental thing that I'm using here is actually from an asset that was put for free on the marketplace on Unreal that comes from the Paragon team. There was a game called Paragons, and they had a lot of models, and they did a really good work. And one of the things that they had in there was this shader for eyes. And I remember I took that apart and looked at it and said, this is fantastic. And I've been working with it and building off of it for a while now. And I find it very useful for many projects that I've worked on, especially this part right here, aside from depth and index of refraction and all that stuff. If we look at one that's called pupil scale, here it is, this one by itself. If I play with that value, I have it set up so that when I set it to 0, it's about as small as that pinhole. That's about as small as it should be for our iris. So if I bring that up to 1, that's general all purpose, and if I bring it up to 2, it's like fully dilated at that point, which is you have to be on something pretty strong to get to that. But also, I don't think even in our fear response, we never get that big. But you can use it. I set it so that 2, it's the absolute most, 1 is average, and then 0 is what it shouldn't be any less than that. All right, so this value, the reason why I'm bringing this up is because we're going to expose this value, and we're going to export animation from Maya that has that data that then is going to drive this shader in real time. So that's what we're going to do here, and that's what this video is about, how to create, aside from providing all of these assets for you to be able to use, free of use. I mean, you have the stuff from Paragon, that's free, and it was given to us by Unreal as part of a package deal. You can download it yourself. It should still be there. It should still be in the free items, and you should be able to you use any of the things that I'm going to show you, including the plugins that I have for Maya. These are all MIT licenses. You can use them to your. You can even monetize them if you want to. But there's tools in there that you should be able to use, and yeah. So let's get to it. Let's see what we can do in Maya first. What kind of setups we can do there, and we're going to then see how we bring that into Unreal. And we're going to see how we can get that to work well in a pipeline that's functional. So first thing we need to we have to pull the band-aid off real quick on this one is the viewport in Maya. Okay, so the nicest way I can put it is it's very limited, and the concept of shaders is pretty much limited to materials for the most part. However, there was something that was added to Maya that not a lot of people are aware of. If I open up my materials here, you're going to see that the file that I provided comes with a shader effects shader that will help us. It will be enough to be able to know what we're doing inside of Maya and to export the correct data so that we can then connect that in Unreal. Now, this shader, you can open it up and make changes on all, but it may look like a big shader, but this is actually nothing. This is very tiny. It's just that when you're using nodes, every little tiny thing, like creating a vector, is like you're building it from all its little pieces. You put it together in a node, and then that connects to another thing, which then has to break the components. You can't just type .x or whatever. So anyways, it's not a really big deal of a shader. So feel free to use this and change it and do whatever you want with it. I've just made it so that you can connect things to it that are going to help us today. And here above it, we have a blend shader. That's a very standard shader, but it wouldn't give us the ability to change like for example, if I do the same thing I was doing in Unreal, put that off to the side here. Without Windows being a jerk. Okay, so if I go here now, and I look at, you'll notice that I have something called pupil scale, exactly named the same way. You can do the exact same thing that we were doing over there. Even go to that crazy dilated state. So this we're going to animate. We're going to have controllers that are going to pipe to this value here, and then we're going to see in real time that reaction. We're going to make a really very basic animation just to see if it works. And then we're going to bring it into Unreal, and then we're going to see if our rig and our controls were effective in what we needed to do. Okay, so the first thing that we're going to look at, because I'm going to use multiple methods here. It's not just spheres. I'm also going to show you how you could approach a mesh with a texture on it, and how you could take control of that in a way that's more user-friendly. So the first thing I'm going to do here is I'm just going to talk about the sphere real quick. So this mesh is the one we had in Unreal. And we have that shader effects shader to be able to do the things that we want to do for real time. The UV has been projected from the front. For the front, like if I select this and I go into UVs, this is what it looks like. The front faces have been projected that way. If I go to UV sets, I don't have the second UV on this one, but it's okay. It's not a big deal. But if you take a normal sphere, you basically have this, like what we have here in the corners across the board with a seam in the back, and it would go all the way around. But what I've done here is I've cut the front off and made it into a texture that we can use. Okay, so the UVs are done here. Even if it's lopsided here, it's okay. That's a mistake on my end. It doesn't change anything because the faces in the front have been projected planarly forward, so it should be still precise even if the edges are not quite right. And this is not the same mesh. By looking at it, I must have exported a different mesh, but it's so close to this, it's almost identical. Okay. All right, so let's see now. Let's say I want to rig this up so that it has a standard look at a target. So I'm going to create two versions of this. I'm going to copy this twice. I'm going to make 2 copies, about something like that. And now we're going to be a little bit more precise with our numbers. So it seems to be around minus 1.3. So that means this one's going to be 1.3. Okay, that's where my mesh is going to stand. So then now what I'm going to do is I'm going to create, using the Rigonomicon shelf, which has access to bacon strip plugins. If you haven't checked this out yet, please go to rigonomicon.com. In the download section, you will find it there. You can install this for free with an MIT license in Maya for 2024 plus. And it works on everything, Mac, PC, or Windows, and Linux. So it works on everything, and you should have it for whatever version you are using if you're using Maya. Okay, so I'm going to click on this button. What it's going to do is it's going to create a joint with a special visual, and I'm going to make it so that it is exactly in the same center piece as this ball here, as that eyeball. So all I'm going to do is I'm going to right click here, and I'm going to go match translation and rotation. It should match it. Now selecting this is not going to be easy because even though I have X-ray on it, it's not going to prioritize selecting it. So what I'm going to do is I'm going to change this already from locator to a sphere. Let's see. How big does this have to be? About, I guess 2 is good. And solid visibility, I'm going to get rid of that. So it's just the wireframe. So we have this thing. And that should be good enough for this. And I'm going to make a clone of this. And I'm going to select that one. And then I'm going to match the 2. So now I have the 2. I'm going to start naming things correctly. So this is not a bacon joint, even though, yes, technically it's a bacon joint. It's a bacon strip visual on top of a joint from Maya. So this is going to be I right, using Unreal nomenclature, which is all lowercase, and the left and right is always at the end. So this is going to be I left. Okay, so far so good. Now, one thing we're going to have to decide on right away is the direction in which the eye points, which axis we want to use. Right now, this object is aligned with the world. Generally, I like everything, like if I'm going to use an aim constraint in Maya, I want it to be the x-axis that points forward. So just looking at this, I see that the x-axis is pointing to the right, and it's the z-axis that's actually pointing forward. So we want the x to point forward. So in order for this to point forward with x, it's our favorite. Rotate is going to be minus 90. And let's see, does it, oh, wait, if I go to object, and I press W now, yeah. Object, there we go. I knew the math was right, so it has to be some sort of display issue. It's the reason why I couldn't see which direction it was pointing in was because I was to know what the axis I'm using is basically the W. So if we want to, we could use this button here, and we have to turn on X-ray mode here. So that makes all joints have X-ray. So now I can see the axis, and sure enough, this one is pointing now in the right direction. If I grab this and I add the axis, we have to fix it. So once again, rotate minus 90. We are not going to be leaving it like minus 90 for very long. These are going to be zeroed out very quickly because that is a gimbal lock, and animating that would be a nightmare. Even though it's a constraint, it still has to bake the values and export them. You would have some wonky effects happening in Unreal. So we need to clean that up. First thing I'm going to do then is going to create I'm going to create a new node. I'm going to make it a little bit smaller. Something like that. And I'm going to call this root. And I'm going to select this object and this joint, and then this last, and press P. So now if I move this They both will follow because they inherit this object's transform. So now I have everything set up. This is basically what will be exported once I have it skinned. So we're going to do the skinning right away. But first, I'm going to zero this out. I'm just going to go to freeze 0 by joint orient. Book. Now both of these should be zeroed out. We're aware of, if you're not aware of this, the joint orient value that goes into a joint contains the initial rotation, which is not going to interfere with our animation. That is probably, in a nutshell, why we use freezing and why we use joints. Also, joints are the only thing that is permitted by Maya to be used for skinning. So we wouldn't be able to skin this if it wasn't a joint. So if I grab this joint and I shift select the sphere, I can go into skin. Let's see, under rigging, skin, bind skin. I should have the default one. If I believe this is default. And I think I can actually go to reset settings. There you go. Okay, so joint hierarchy, max influence 2. So this is the default. So if you don't have this, classic linear distance, joint hierarchy, and binding method is closest. Okay, so we're not using anything fancy like a heat map or geodesic. That'll ruin our day, because at the end of the day, this should only need one influence, really. There's one bone and it has one influence. Okay, so I'm going to apply that. And if I do the same thing over here, I select that joint. It's a very simple rig. And I select that sphere and I go skin. Well, I've got it open here, so I'm just going to do that. So now if I select this and I move it, now these spheres are not part of the hierarchy, but they are skinned to something that is. So if I were to rotate this, Maya's doing its thing. So we're going to have to fix that. It means maybe I should have set it to max influence of 1. And here we go. So if I go here, this little window shows up. And it's using the root. It's the hierarchy. Maybe I should have done it by selection. I could always just, I think I can just delete this, remove affected vertices. No, well, anyways. So if I go here and I go select all here, and I go back to paint, it's going to just affect the ones I selected with the eye left, and I go flood. Now it's 100% of that value. Oh, wait, no, there. Now it's correct. Okay, so that's okay. So now if I do this, it should have fixed it. Yes, there's no wonky eye happening anymore. I'm going to fix this guy too, because he's probably got the same problem. Sure enough, select all the vertices. There are buttons to select all verts, and I can always just right click and go select all, something like that. It's in here somewhere. Anyways, aha, one of my favorite things in Maya. There we go. All right, double clicked it. Now we're in here. If I go to paint and then select, okay, there we go. All right, so I selected everything. Let's not mess with it. And let's make sure that we're at 100% and we flood it. Actually, we should be in paint when we do that. There we go. These little tiny mistakes, I find, at least I've been told, are helpful. And I find it's important to show you whenever I make little goofs like that, because sometimes I'm fighting the UI. And if you know any methods that are faster or better than what I'm doing, by all means, let me know, because I always like to improve. But if you're watching this and you're struggling, take a look at how I'm switching between things to be able to get it to work and do the thing that I need, because that can be helpful for you. So let's see if it worked. Yes, it worked just fine. Now we have that skin. Everything's lovely. Okay, so now we got to get these eyes to look at something. So what I'm going to do is I'm going to give it some targets. I'm going to also get rid of the axis. Oh, no, actually, I'm going to leave the axis on because we're going to need it. So I'm going to file, save scene as. This is SM stands for static mesh. I'm going to call this SKM for skeletal mesh, and I'm going to give it a new name, V2, even though it's, yeah, okay. So this should be fine. I'll be fine with this naming, because I had everything done but Windows decided to update. If it happens again, I'll probably start making my videos in Linux because yeah, I don't have that kind of problem in just about any other OS. Maybe I'll do it on the Mac next time. Okay, so next thing we're going to do is I'm going to create a target for it to look at, and I'm going to make it so that it matches this thing in position. Whoops, sorry, what am I doing there? Match translation. So I'm just deselecting that, so I just end up with that instead of having to reselect it. So anyways, this is going to be my target object. So this object should have the -1.3 that we had before, and it's got the height of the eyeball, which is 1, and I moved it all the way out here. You don't have to worry about where here is, because what we're going to be doing is we're going to use this to create a couple of targets. So the first thing I'm going to do, though, is I'm going to change its shape from a locator to a circle. Circle is here. And in order to get the circle to point in the right direction, it needs an orientation change of 90. There we go. Okay, and it doesn't have to be as big as this, where maybe we'll make it 0.5, something like that. Okay, the point of what I'm doing here, it has to do with the fact that this is only the shape that's being affected, okay? Just because there's a shape orientation of 90 doesn't mean there's a transform of 90. Transform is still 0. Life is good, nothing to worry about. So I'm going to press Control-D to duplicate this object, and I'm just going to put this to 1.3. So now it's the other side of the eye, but it's a straight line from one to the other. And then I'm going to duplicate it again, and this time I'm going to make sure it's exactly at 0, and I'm going to change its shape to be this thing called goggles. I put this one in here specifically for this kind of thing. Also needs a 90-degree rotate. That's an offset. This one doesn't need an orientation. Okay, so we're getting there. We're getting there. So something like this. Maybe if I get the feeling this is like a 5. Well, it looks good enough. It doesn't have to be perfect. Actually, we need it a little bit bigger. 5.2. Let me just select that again. 5.2. There we go. I figured because it's 1.3, so it's a 6, a 12. Anyways, 5.2 is probably going to be just fine, and we could change the size of these guys a little bit here so that it fits a little better. Remember, this is just visual, and it's not important. What is important is that where you have precise coordinates for these things, everything has a precise value, and we're good to go. So what I'm going to do is I'm going to make these two children of this object. I just pressed P for parent. So now if I move this around, there we go. I must have pressed something that got rid of my texture. So let's see here. What's going on? Okay, so I must have pressed a button at some point by accident that turned off my textures. Not a big deal. There it is. Okay, so we're good to go. Like we just tested this. Everything's hunky-dory. This is our control rig. So this will be, like normally this would be part of something else. But in this case, we can just call this I underscore control root. And this can be C underscore its controller I left. And then this one controller I right. Maybe we can call this one controller. This is not in convention with everything else. C underscore I root. Okay, so everything is good for controllers, and this thing also has been named correctly. I'm going to get rid of displaying shapes so I can just see the hierarchy. Very simple hierarchy. Whoop, something not right here. This is the right, and this is the left. What's wrong with me? Okay, so left here. It happens. These are things that happen. As long as we catch them and we fix them, life is good. So this is the right and that's the left. In fact, let's help ourselves out here. Let's change the color of this because it's the parent object. Always change the color of the parent wireframe color. And I'm going to make that yellow, which means the other two will inherit. That's why I did that one first. And then these two, I will make blue. And I'll make this one and this one pink. I think that's good enough. That's good for right now. And one other thing that I'm going to do is I'm going to select this object and then this joint. And I'm going to right click on shape. And I'm going to add something called a bacon shape line. And I'm selecting it exactly in the same way that I would for a constraint with an aim constraint. That's on purpose, so it makes it easier. So now once we get the rotation constraint going so that it points at it, it will always point towards this thing. Right now, if I move it, the line's pointing at it, but the eye is not rotating correctly, right? So we're doing good. So now all we need to do is figure out how to do this eyeball so that we can constrain it. So let's just go to rigging. We're going to go to constraint. And we're going to look at the aim constraint. We're bringing up the options. Okay, for the most part, we're not going to do any maintain offsets because we want it to snap into place and be very precise. For an aim constraint, you have to think of it as two steps. First step is which axis is going to point to the object, right? It's going to aim at along the x-axis. That's why I kept the view so we can see which axis it is, and we know we did some work to get the x to point to forward. So aim vector is going to be 1, 0, 0 because that's x. The up vector means which axis is the one that we're going to take control in order for this to work to make it spin on that line, because there's an infinite number of solutions for it to have the x point at the object. It can spin 360 degrees in any direction, and the x is still pointing to is still pointing forward, is correct. So up vector is the second thing that we need to lock down. So we're going to use its y-axis to lock it down, and then we have to tell it to what we want to lock it down to. So you could even use the scene up, or world. That should say world up, because this is. One thing, okay, I'm going to say these old constraints have very loose naming names and tags, and they should have been cleaned up a long time ago. But unfortunately, here we are. So the world up type, this should be the up type of the object of what what we're going to use as a reference. So a reference up type should be here. You could, and the scene up should have been called world up because it's going to use the worlds up. And then you have an objects up, and this is a bit, it's not so great because object up isn't going to be what you think it is. It's going to use another object as the up. So you have to translate the object in order to make it point in the right direction. So we're going to use the object rotation up. I know it sucks, but you'll know you have the right one because it's asking for a name of an object. And as much as I hate having to use naming convention like that, I'm going to take this one over here, like C, I'm going to copy that. I'm going to paste it over here. And I'm going to use this object's its y-axis. So I'm going to match both y-axis and make the x-axis point to the object by doing this. So I select this object. I shift select the joint, which is for the eye. And I, this doesn't look right. It looks like I may have accidentally typed something while I was selecting things. And that should work now. So if I applied it to that one, it should be okay. It's pointing at the object. And if I spin this, it should spin the eye. There we go. So that's what we're looking for. I'm going to do the same thing over here. Copy that, paste that over here, and then select this thing and select the joint. And this is all ready for me. So I'm going to go apply. So that means that now if I move this around, the eyes will look at it. And you have to look at, you don't need to really understand stereoscopic vision and how it works. You just have to look at a mirror and look at your own eyes. Like, you'll see that your eyes don't cross at the like they don't go cross-eyed to look at a thing. It's only when objects are very close that you get that cross-eye thing. So maybe when you're up close, you can do like this when they're trying to read something directly in front of them, and then when you're far away, it does that kind of thing. But for the most part, you're going to try to keep them parallel to each other, because that's kind of how depth perception works. The two images are sent to the brain, and it can figure out depth based on the difference between the two. That's something that we're going to have to just kind of get used to. And when we're animating, I see a lot of eyes that are cross-eyed in many animations. So just keep that in mind. Try to avoid having a cross-eye. Nothing says inexperienced when your character starts going cross-eye. So keep an eye on that. Like that's one of the things that I use as a reference. I'm going to shift select both of these and get rid of the axis. So we're going to keep it nice and clean. I don't know if you can hear that, but my cat is not happy that this video is going to be recorded 2 times. It's time for his fun time. All good, all good. So now what we're going to do is we're going to save this. I'm going to put another version. So this is eyeball. This is version 2 _02. So it's a different run. Okay. You got to sit down, buddy. You got to make your choice. This is typical of a Rigonomicon.com video where I actually spend some time with my cat to get him to sit down somewhere where I can do the rest of the video. Okay, so he still hasn't found his place, but as long as he doesn't sit on the keyboard, he's sitting next to it. So hopefully, I'll let you know if he types something, or I do something inadvertent because of his tail. He's a funny little guy. Okay, so if we were to export something like this, even though we're adding keys to this object, these joints have the little blue tag on rotation, meaning they're being driven, being calculated. So what we're going to do now is I'm going to set up a selection set of what actually gets exported. So I'm definitely going to want this, and this. Like the fact that constraints get shown up in a DAG objects only hierarchy is still like you got to understand that there's a lot of leftovers. This is one of the reasons why I don't use the aim constraint. I actually use my own look at constraint, so it avoids adding these things that are from like 20 years ago. There's a lot of stuff in Maya still that's floating around that should be cleaned out, frankly. But I'm just going to use this, and I'm going to say, look, this is what it really counts. This object, and as long as there's no object that's parented to these things that shouldn't be here, there's no problem. We're exporting things that have a hierarchy, so that are all part, like are hierarchy complete. Meaning, if I have the I right, that its parent is root, so that's also being exported, so there's no problem. And that's the same thing for I left. And we have the 2 meshes. This is what we're going to actually export. And the FBX that we're going to create will have those constraints converted into baked values. So it'll put a key for every frame, but then the Unreal data compressor will take that data and convert it into something that doesn't weigh too much. So a lot of moving parts here. Just know, keep it simple. Keep it to just what you're going to need inside of Unreal. This stuff, you don't need to export anything here. So I'm going to just go create sets with options, right? And I'm going to call it UE5 underscore export. And I'm going to apply. And then now we have, basically, this is what we're going to end up exporting to Unreal. And anytime we need to export, we just right click on that and we do select set members. And then we click on export selected. This is one of the cleaner ways that I've found working in Maya in particular to be able to export. There's other systems also that I developed that we'll talk about at some point, where you have basically this, what I call an export map or a character map. It's basically similar to what you have in human IK, where you basically define what's the arm, what's the leg, and whatever it is that you have, and then you have an attribute that says, am I exportable? And then when you click on the export tool, it will say, I will look for that and then export it or not. So you don't have to deal with export sets and all that stuff. The object itself has the parameter that you're looking for that will control what gets exported and what doesn't. Okay, so with that in mind, where I'm just going to do a file save here. We've completed this setup, but I'm also now going to use this setup to show you how you could animate an object that isn't a round sphere. So right now this is easy peasy because we have an aim constraint and the eye is aiming at this target, and we can control exactly how everything works really nice. And one of the problems with this is that if your character does not have a spherical eye, what do? So let's just start by creating what I would call a plane with a texture on it, and imagine that that's a mesh that's on our character and that we want to animate the eye through UV offsets, and how we can maybe use this setup that we have right now to drive that. So we wouldn't have the eyeballs, so the eyeballs would be hidden. We wouldn't see this, but we'd still have, even if our character doesn't have eyeballs meshes, it still has an eyeball area. So this would be inside the character's head. But the eye, imagine I don't know, you've got like a cartoon character and the eye is modeled into the head. And you need to have a texture on there and you need to animate the eye somehow. And there's no actual sphere to turn. Okay, all that to say, we're going to create polygons plane with options. And I'm going to set it to 2 and 2 because I think that's a good size. That's fine. I think that'll be just fine. What I'm going to do is I'm going to make this thing match this eyeball, so I can match just the translation so that I can I can do this. I'm going to move it forward. This is roughly where, let's say this is where the eye is, where the mesh would be. And now I'm going to apply material to it. I'm going to open this up, and I have over here this window, and I have this material already set up. But what I'm going to do is I'm going to duplicate it, create duplicate. No, edit duplicate. Here we go. Shader network. There we go. So now we have another one. The reason why I'm doing this, I'm going to press the number 3 on my keyboard, so I can see all these extra things that are here. It's not giving me everything. Like this thing clearly has a U coordinate offset, and that has a V coordinate offset, which I really need in a minute. And this one doesn't. This one has it. This one doesn't. Okay. So what if I open this up? Oh, so yeah, a quick word about this. It seems to be the old. Hang on a second. This is weird. Okay, if I go Control Duplicate. Just like that. Does it do it correctly? That is so weird. It's using, like, it's clearly not what's here. Okay, and it's this has got the old stuff that I've already modified. I could reopen Maya. Maybe there's an issue there, but maybe what I can do is, you should have this if you opened it. This is just Maya doing it. Like, I had a full hang of the system, so but I don't think that's related to this, but it's this is probably just Maya being silly. So what I'm going to do is we're going to keep that over here, and I'm going to use this one for the eyeballs, that, or the mesh that's going to be it's going to be over here. And we can always reuse it if not. And then over here, I'm going to select it again. And wait, where is it? Is it this one? Yeah, it's this one. Because I have to right click on this and assign, so I can't select it in that little tiny viewport sometimes. Anyways, so it's applied it to that object there. Well, that's shader effects one. Actually, that's not the one we want. we want this one. So it was this one, sorry about that. These things happen. We're gonna do this, boom. Okay, so now we're good. Even though this looks like it's selected, this is the one that is clear. We're gonna change the color of the iris. So let's change it to something like a nice, let's go brown. How about that? That's a little too orange, maybe a little darker. Actually, we have iris darkness. I put it in here for us. So I can lower that. There we go. So we have a nice hazel color for our mesh. And the thing that's important here to note is, and you should have this, I would imagine you don't have the problem that I do with the refresh. When I duplicated it, for some reason, it went back to its old thing. But if I wanted to, I could have just gone in here and fixed it, because all I did was add U-coordinate offset, and I exposed the iris map for in case someone wants to use their own maps. If you go here and click on this right here, you'll see that if I click on the texture, that's the texture I'm using. This is what I'm using in, like we saw before. This is what I'm using in Unreal, and I'm using this in Maya again. And I've rewritten a little shader to be able to at least get the eye to have the proper color and the proper eye dilation, because we're going to be animating the eye dilating in Maya, and we want to export that. Well, materials in Maya are a little bit, they're a little old school. And there is something lovely in Maya, though, that not a lot of people are aware of. It's called shader effects. And that's what we saw here for a moment. This is not a big shader. There's not a lot of things going on here. So anyways, point is, now I'm going to show you, like, basically if I wanted to fix this, where I made the modifications over here, I'm taking the UV, and I've got something here that I've exposed as variables, which then get added to the UV, and that then goes into the rest of the equation for my pupil to dilate and everything else. So the whole point of this is that we have the offset exposed in the over here, U and V, and we're going to be plugging some values in order to be able to move an object around. So first, let's see what we can do. Okay, so let's see what if I were to create a new object here, and I'm going to actually, for the sake of knowing what's going on here, we're going to take this object and match it here. Later we can move it further forward, it doesn't matter. The idea here is that you have a mesh with a planar projection and a texture on it, and we're going to move this iris around, the pupil around, to be able to show how we could animate this. And then I'm going to show you a little tool that I have that makes things a lot easier. Okay, so I'm going to take this and I'm going to match it to this. I'm going to go match and match translation. And already it's the right size, but this is not very conducive. I'm gonna do some things here. I'm gonna hide this for a moment, and we're gonna see what we can do with this to give us a better sense of that box. So I'm gonna set the shape's size to 0, so it's flat now. Now it's a cross. And the other thing I'm going to do is I'm going to add another shape on top of that. So it's the same object. It's just got 2 shapes on it. I'm going to add a bacon shaped bone. Okay. And now you have 2 of them, and it should be on the list here. The second one, I'm going to switch it to a box. So let me see if I can find a square. There we go, square. Okay. Now I'm going to change it to 1, right? Because each one of these from the center out is 1. So a total of 2. And I'm going to rotate it, I think, once again. Is this orientation? Yeah, like that. I'm going to get rid of the solid visibility because that's going to be a problem. And maybe I'm going to make the wire thickness a little bit more, like something like 4. So this is a nice little grid that we have here. I'm going to change the whole thing's color. Let's see here. Display. Wire frame color. I'm going to turn it all to yellow. So this is what we have here. Now I'm going to create another one of these little objects. Remember, these are all joints with a visual, with the bacon strip visual tools. This is really handy. If you don't have them, I strongly suggest getting them. You have everything from X-rays to visibility of wires and visibility of even you can make the lines even thicker without affecting the entire scene, like in the options in Maya. It's weird. Maya should have this, but to be honest with you, there's a lot of features that are in Maya, but they're just not accessible because they don't have a UI or a plugin that takes advantage of it. So that's what Bacon Strip is. It kind of makes things available that should have been there. So I'm going to grab this guy and I'm going to match it to this. Boop. And now this guy, he's, let me see if I can select it. It should be down here. It's this guy. So already that shape is not going to do. I'm going to put it, I think I'll just make a circle. What's important is I'm going to make sure I'm in object mode, is to understand where its X and Y is. So X is going to go this way. Y is going to go that way. That's positive, that's negative. That's going to come into play very soon. So if I shift select this like so, and press P, it'll be child now. If I look here, we're going to be naming stuff. It's child now of this thing. So this is, we're going to call this UV UV I don't know, view UV view. So this is a UV view, our root rather, and then we have this little guy who is going to be rotated 90 degrees, and that's way too big for a point where we're going to hit with just using the control button to make this slower. If you don't know, this little button here that looks like an Uno reverse thing, that thing is what control. If you click it, it'll change the rate at which. Like now, I'm not holding anything, and if I middle click drag in the viewport, anything I have selected here will be slower. But if you don't have it, like if you have it at the default, which is this usually, you press Control and you can get the same effect. It'll slow it down. I think Shift is faster. Anyways, point is, I've got it set to something that's usable. I'm going to make it so that I can see it nice and clean. And wherever I move, like I'm going to just double check. X is positive in that way, negative over here. So it's going to -1, it's going to +1. I'm just getting a hand, just getting an understanding of what these coordinates are that it's going to be feeding us, and how we can control it so that it goes into the correct spot. So that's all we need from it, is the translate X and Y. So what we could do is now bring out the plane again. Okay, and now I can select this object, right? And what I want to do is move this UV on this plane so that it follows this object around. Okay, and we're facing it this way. So now what I'm going to do is I'm going to go into the over here and make sure I've got the correct one. This is the one that we're dealing with. Yeah, it has the brown eye. So we're going to close this, or the hazel eye. It's selected still. I'm going to just single click this to open up the node editor. I'm going to slide that over here, and I'm going to Alt middle click it, drag it out here, and we're gonna go over here and create a new one. So the first thing that we're gonna do is bring in the thing that we still had selected. Press the 3 button. It'll give us the entire output and all the things that are here. Then I'm going to select this node and I'm going to do plus, and it's going to show up here. All right. So this bacon joint is not a good name. This is going to be the UV underscore target. So the UV target. Okay. I'm going to open this up so we can see the translation X. And all I'm going to do for now is just connect the U here and the V to the Y, right? And I'm going to see what behavior we have. Okay, so the X is in reverse and the Y is also in reverse. I could go into details as to why that's happening, but what's important is when you're rigging, when you see behavior like this, it's very easy to fix. All you need to do is change the values that are coming in here so that in this case, I'm also noticing that If it's the 0 is right, but if I move it halfway, it's gone all the way. So that means I need to take only a half of this value. So not only is it negative, but it's also, I got to scale it down so that the values don't push it too far too quickly. So what I'm going to do is in here, I'm going to press tab. Actually, you know what? Just to make it easier for everybody, I'm just going to click this button here. It's going to show you all the types of nodes that you can generate. Quick note. One thing I've learned is not to trust the default nodes that go into Maya. There's a lot of mental array nodes that used to be very handy that are gone. So I'll be making my own nodes as we go for basic things like for math. And also hopefully it'll be a little bit more optimized because the way they're set up here, they're over-engineered for general purpose. But we need just basic stuff here. Like, so right now we just need to take these two values and multiply them by minus 0.5 or divide them by -2. So either one of those two methods will work. So if we divide, let's see, what does that give us? Take one object. Okay, so the only problem with this thing is that I can't set the second value with, yeah, I can. So, okay, so I'm going to take this, and then I'm going to take the translate x, and I'm going to divide it by -2. And I was able to do it through the translate. Not all inputs are the same. None of these nodes are it's not very consistent. So I'm going to do that, and I'm going to do that again. I'm just going to Control D. That way I have the -2 already punched in. I take this value, punch it into the input 1, and I'm going to put output there. There are many ways we could have done this. This particular node you should have. If you don't have it, then you can use any of the other ones that'll get you there. There's one in particular that I've seen multiple times that can kind of come in handy. It's been in Maya for a long time. You can trust that it'll still be there. That's this one here, multiply, divide. This one has the added advantage of being able to put in multiple values because it's meant for a vector. So you do is connect the x to this, the y to this, and in here you'd put the you put -2 here and -2 here, and make sure that your operation's set to divide. And then you could, in the output, take the x from this one, connect it there, and the y from this one and connect it there. Both of these will give us what we need. So I'll just leave that there because it's just a reminder that we can use either system. Now what I'm going to do is I'm going to select this object and move it, and sure enough, it moves the iris 1 to 1. So in what you can do to do this yourself with your model, what you can do is you can take this mesh and cut the mesh, like literally cut it, so that it has still the planar projection on it, and then you place that into your character's head. Or you take the triangles that are there, and you do a planar projection that matches this square here. Either way, you're making a planar projection or keeping a planar projection, and you're connecting these two objects together. Now, to animate this, it's not the worst because you'd have the mesh over here, and your control could be off to the side, and you're just animating it relative to these two things. You can even go off screen here if you wanted to. You can make it so that this object cannot go past this, but there might be some value in being able to go off the plane for some ways that it looks. So this is great, and then you could animate this directly and then export it. However, if you're animating a character that's picking things up or looking at things in the world, this is a really difficult way to animate. So what we're going to do is we're going to have some fun here. We're going to do the exact same thing we did last time with the aim, but this time we're going to select this object, which is the target, and we're going to select the ball. And all I'm going to do is I'm going to right click in here in constraints and use the UV projection button. And what you're going to notice is now the rotation of this sphere will determine where the eye goes. And what it's doing, so you're going to notice, so I'm going to just move this so that it's on this plane or close to it. Like, it doesn't have to be perfect. You can see clearly that that little target that we were animating before by hand now is automatically finding the place where this line intersects the plane. And we're using that math based on this object's rotation, to determine where that coordinate would be. So if your character is animated through this object, like we did with the spheres, now you have a very precise way of getting your animation for the UV offsets. And what you would do is you would export this data. We're gonna do an example of this in just a moment with the pupil. It's the exact same thing. We'd export the values of these, for example, this over here, this object, or we'd put a custom attribute onto this other, any node, any bone that is on the skeleton. We can add in here in the channel box. We can go to object. You can go to edit, add attribute. You can add any attribute to it, and when you export it to Unreal, Unreal will see it, and then we'll see the keys that are on this attribute. And based on its name, you can connect it to anything in Unreal. So in the case of our pupil scale we saw before, when we were in Unreal, that will control the dilation of the eye. In this case, you could have UV offset, and you could make it so that it's the U coordinate offset, left eye and right eye, and so on. And you just export that data, put it, make sure that it's connected to some sort of channel, some sort of attribute on your skeleton, and that data then will live on the export, which Unreal can then pick up and do the exact same thing we're doing here, but in Unreal. Okay, so with that in mind, I'm just going to save this. This is number 3 of version 2. I know that's confusing, but it makes sense. There's each version. Anyways, you're saving. Do whatever you'd like for your saving. Okay, so this is no longer what we need. Now we're going to go back to just these two guys that we had. Yes, this is happening because we are offsetting the UVs based on this thing. So now we're going to detach it and turn it back to blue, or reload. We can also just reload, actually, because when we duplicated the shader, for whatever reason, I couldn't leave the old one on this one. So I'm just gonna, good thing we save often. Here we go. We're back to this one with, and this is all we need for for doing the pupil and having it dilate, so that we can animate that as well. So what I'm going to do is, first thing we need to do is always remember this is what we export. So we select the set members, and we know that these are the objects that are going to be exported. These we shouldn't include in the export as objects that will contain data. It's going to be part of the skin. You do have an option, if you had a morph, or rather a blend shape on these, you can make sure that they're included, so that when you animate your blend shapes, the values get exported as well. So in that kind of scenario, you would do that. But for right now, the skeleton is just this, right? Ignoring the constraints. This is the actual skeleton, right? So this is what Unreal is going to be really seeing. So we need to go and put a value in here for it to understand for the pupil scale, for it to receive the data. So I'm going to select this root node that we have, and I'm going to edit it and go add attributes. I'm going to name it exactly the same that it is in Unreal, which is pupil scale with capitals in the right place. So capital P, capital S. It's a float. We don't need to worry too much about the minimums and maximums, but I'll do it anyways. And I'll go, okay. And just to show you that this is the important one, this one's named pupil scale. Whatever's here will get exported. In our control, because I'm going to use this to animate where the eyes are looking and setting keys. So if that's the case, this object will also contain its own. And just so that it's super clear, I'm going to go add attribute, and I'm going to say dilation. It's something that does not exist in, I think I spelled that right, yeah. Dilation, so I'm going to do the same thing here. I'm going to say 0 and 2 and 1. The default is 1. It's a float, meaning it's a number between, like it has a decimal. It's not an integer where it's just a 1, a 2, a 3. You can't have a 2.5. And it's not a true or false. And it's not three numbers together. It's not a string of text. And it's not an enum that's a numerator, but that's a whole other thing. That I guess I won't go into programming stuff in these videos. So, okay, so let's just call it dilation and go add. So that's just to make it super clear that this object is a thing that we animate with, and it's going to drive the values of this that we're going to export, and that's the values that are here is what's important. So I'm going to hook this guy's dilation value as the controller, and I'm going to bring it into another node editor. I just single clicked, and I'm going to go plus so we don't lose anything. And I'm going to simply select this object and this object, and I'm going to go plus. There we go. So we got the controller of the root. I'm going to put that on the left because that's the thing that controls everything. And then we have the root node from the skeleton that goes over here. And in this case, I'm going to select them both and press 3 so I can see more. And you're going to see that you have something called pupil scale right here. So already I'm just going to connect that to that. And I'm just going to move this over on another screen so I can see what we're doing. If I change this value to something like 0.97, if I select the skeleton, you're going to see that it's being driven by something, and it's also 0.97. So excellent, we're doing good. Okay, I'm going to bring this over, and I'm also going to press the material so that I can select the material that has all the good stuff. And I've just got it selected, and then I can close this. And I can press the plus button here, and it will bring out what I had selected. And this guy will also receive the dilation into the pupil scale right there. And that will drive, I'm going to move this out of the way. If I now select this object and I go to dilation, I should be able to see the eyes dilating, and I can control it. So now inside of Maya, I'm able to see and control the dilation of our character. So now I'm just going to do some really, I'm just going to save this. And this is going to be number 4. It's good to have backups. You can delete the backups when you're done with everything. But in the meantime, it makes it so that anything we do, it's good to go. In case something crashes or whatever like before. And I could have continued from that, but it was just it was best just to start over. Okay, so I'm gonna go and press S. That's something that a lot of people like. This is against my usual way of doing things because I usually cherry pick and pick only the things that need to be animated, but in this case, by pressing S, I'm just adding keys to translation and rotation, which is what I want for this object. And the dilation's also been included because it's an attribute that I added here. Radius is being blocked, and visibility, I think I can do a, it doesn't matter. There was a way of, there it is, lock selected, there we go. So it's always on, and we're not gonna be animating that by accident. Okay, so if I added a key, I'm gonna go over here where the character is gonna look at something else over here. Maybe rotate that a little bit to maintain its stereoscopic capacity. And it should have auto-keyed it, right? And maybe like as it moves, it's like, whoa, and then it goes back to normal over here. And maybe we can do a little bit of an overshot. And just a little bit like that, so that way we go, and then it holds it there for a little bit. I'm gonna also, well, I'm just gonna set key here. So it's gonna look at that, and then maybe it's gonna look to the other side. And this animation is gonna be trash, I know it is, but it's, look, I'm just doing this to make sure, careful with the eye rotation. Maybe I should have used the world up, actually, for the like, you don't really want eyeballs turning and spinning like that. So maybe we could have a world up next time. Or relative to the head bone, so it always follows the head because the eyes don't spin. All right, so I'll keep that in mind. The next time we do the aim constraint, when we pick what the up is, make sure that its up is going to be the one for the head bone. I could have used the up on the root node, that too. That could have been good. And then I'm going to just do dilation like this. So we're going to see, the idea is just to see it. And if it looks exactly the same when we get to Unreal, just making sure that this crappy animation actually is okay. Is, well, not okay, is that it looks the same. And then maybe at 130, it's holding it here for a little bit longer, maybe. I'm just trying to get it so that we can see clearly that this is over the top, but you get the idea. And then maybe it comes right back to its initial key. Copy. And we're going to go paste. Paste. Nope, wrong place. So I have to come here and then paste it. Okay, now it's okay. You can tell that I'm used to other softwares for this one. I usually just do a selection like that and then just shift clone it and make a duplicate that way. Anyways, keys here are not so great because if you have a lot of keys, Maya will chug. And that's a real problem. Okay, so we have this. Let's see what it looks like. It's terrible, but whatever. The important thing is that we have what we need for our export. So I'm going to go to frame 0, and I'm going to do select set members. First one, you're going to need the skeletal mesh. Export it. Actually, you know what? We can export all of it. And then so export selection, and then we're in Unreal. We'll be able to export the import the animation and the skeletal mesh and its skeleton directly. So I'm going to go UE5 here. I've got a projects folder just for Unreal type things. By the way, this word raw is something that could be useful for some people that don't know what it is. If you're not part of video, if you don't do video games and you're not in that field, it might not be so useful to you. But to understand that normally we call this a source folder where like we put all of our source material and the things that we use in order to generate the things that we use in later, like in other places like Adobe Premiere and all that stuff. So like in video games, though, we try to stay away from using the term source. Because that's usually for programming and for source code. So we use the term raw, which is more for artists. Raw files are the things that are like Photoshop files, like PSDs, Maya files, and so on, and even FBX files, which are technically intermediary files. But these are all, we usually put it in a raw folder, and then in Unreal, it will be loaded in there, and that way we make it easy to understand which files are what. That's just kind of the convention that we have at the moment that I've seen, and you're going to see that the term raw will come up, and you'll know what that really means. Smoothing groups, yes, we want tangents and binormals, absolutely. Smooth mesh, there isn't any, but sure. No selection sets, no. Reference acid content, sure, if it comes in. No triangulation, no. We want animation, yes. And the start and end is the thing. One of the most important things that we have here is to resample all the keys, and it will bake. So constraints, we don't want constraints to be exported because that's a whole ball of that's a whole issue. It's not it doesn't work well yet, and I know there was people that were trying to get it to work in Unity and in Unreal, but just ignore that. So blend shapes, you might want to bring that in if you had blend shapes and data that you wanted to export. Everything else should be okay. by default. There's no shenanigans with scaling. Everything's set to automatic. There's always an issue with Maya and the fact that it's based on the decimeter scale, and basically everything else works on centimeters, sometimes even meters. So Maya is kind of like an in-between. You'll always notice that whenever you bring something from Maya, it's tiny, and just about every other software. So do not use this as a scaling factor. The FBX, I've explained it in other videos. The FBX, what's a kind way of putting this? It's been written to be the least path of resistance. It'll do the simplest thing possible in order to be able to change the scale of something. And that's across the board with the FBX exporter in every software that I've seen versions of it. So in the case of like scale factor of, like, let's say you put it to 10, so it would be 10 times bigger. It's going to create a new node and make that a parent node of the whole thing. It'll go above the root. It's going to introduce a new node, which may not be compatible with what you might have in Unreal. And it's going to use scale. That's a no-no. If you don't know why I have such an allergic reaction to scales, please take a look at the golden rules on the rigonomicon.com, and also take a look at the basics of rigging. You'll understand after seeing that what are the things we're trying to avoid and the headaches we can avoid by not introducing scales into our rigs and into our export data. All right, so with all this, I think we're good. I'm just going to go into the raw folder here, and I'm going to call this SKM eyeballs. And it's going to have the animation as well. For you know, like, you can do it differently, and if you want to, that's not a problem. So over here, what I'm going to do is I'm going to go into the example use, and this, I've already prepared it, and I've got the raw folder. You should have the same, like all of these things. I made I had it already up and running on GitHub. And I put a file there that you should be able to download. So everything that you see here, you should have available to you. If not, please contact me. Just send me a message even on the YouTube videos, and I'll get back to you. Okay, so over here we have an SKM that we just exported. Yep. So I'm going to just bring that in here. Oh. Eyeballs. Here we go. 1030. Yep. So it's got a window that popped up, and that's why I did that. So what we're going to do is we're going to look at it and say, skeletal mesh, yes. And we're going to import the mesh. We're going to create a new skeleton, so there's no skeleton here that currently could help us. It's going to bring in the skinning weights. It's also going to import the animations. One thing I'm going to avoid is I'm going to make sure I do not make it look for any materials or any shenanigans. Do not import textures. Okay, so I'm just going to import that now. It's going to create a whole bunch of stuff. Import all. Now, what it created. All right, so first is the skeleton. Well, skeletal mesh is here. We have an animation sequence. We have a physical asset, which means it'll create bounding boxes around things. This is not super useful for us right now. And it's created the base skeleton. So if we had more animation, we wouldn't be recreating the skeleton every time. We'd just be modifying the one that's there. So if we double click this, bring this out, you're going to see that we have a root and we have the two eyes, and that's good to go. So that they're all connected. See, they're all up here. So if I go now to this is the mesh, right? And if I go F, there we go. So that's good too. And this will be animation. So right here we have a material stats thing, and that's where we're going to get our material from over here. In this case, when I click on here, I will use the one called, unfortunately it's cubic, but this is the correct one. This is material flattened. That's just a preview. What we want is this material here. So if ever you're having trouble with that, you can select an object like this one, and then you can click on the little magnifying glass thing, and it'll show you which one it is. It's just this one. So I'm going to then click on here, and it's going to apply it onto our object. So let's see if I can bring the lighting around here. We might need to change some of the values on it, but if we bring that object into this, so let's see here, eyeball, the example use, we have the eyeballs, we can bring those in here, and they're going to be really tiny, aren't they? Yeah, or really big, one of the two. No, it's usually tiny. Let's see if I press F, yeah, they're there. They're really small, and that could be the reason why we're having trouble with our shader. But if we scale this, I'm going to lock it so that it does all of them at the same time. 15. There we go. You can scale here because you're scaling the entire thing. That's okay when you're at that level. No, there's a little issue here we're going to need to look into. We're going to have to clean that up. It's still too small, huh? Oh boy. Let's see here, 50. Make sure they're all good. There we go. Okay. And maybe we can change some of the material values. We'll make a duplicate of it and just change that one just to make sure that it's good. There's the darkness thing that's not, it's overdoing it. Maybe the UVs were simple, oh, I know what it is. This is not the same mesh as that one. The UVs are different. So that's why it's happening, because this one has two sets of UVs. I should have brought that mesh into Maya. Okay, so what we can do is we can also even just grab this mesh and re-export it, bring it into Maya, and then yada yada. Maybe we can just modify this thing to suit our needs. But first, let's see if we can get the animation to work. One of the things that we're going to have to check is go to the skeleton and curves. There should be this curve, pupil scale, and we're going to hit that there. So if I go to animation and look at the animation they got brought in, you'll see that it automatically, and as easy as that, it added the correct. So in order to fix this, you see the animation is exactly like we had in Maya, except for, of course, for this weird, we turned it into a ramen egg. It's been in soy sauce for too long. But you can see clearly that it is working. But there's a problem with the shader because the mesh that I used didn't have two sets of UVs to be able to control the sclera correctly. So, but it is working. So what I'm going to do is, what we can do is we can fix it real quick, or we can, yeah, let's fix it. Let's just fix it. So what I'm going to do is I'm going to select this mesh. I'm going to go to, let's see, eyeballs should be here. SM eyeball. This is the static mesh eyeball, and it says static mesh. I'm going to right click on it. Let's see if we can fix this quickly. And we're going to go export under asset actions. I'm going to go back to that folder that I was working in. Let's see. Unreal. Projects. UE5. Eyes. Raw. I'm going to call this. I already have something here, but that's not the same thing. This is a UE. This is going to be a UE5 eyeball. It's because there was a difference between how Maya was creating, how I was doing its longitude and latitudinal cuts. I wanted to see if I could do something about that. Collision, no, we don't need it. Morph targets, no, there aren't any, so it wouldn't be a problem. I don't know why I would want that. I just want the mesh, just the mesh. FBX, bake transforms, none. Export. Okay, so now in Maya, hopefully, we will be able to, let's see here. Where's my Maya? There it is. Okay, so hopefully in here, I can do this quickly. Import, and I'm going to go to UE5, eyes, raw, UE5 eyeball. And let's see what happens. It's going to be a big eyeball. And what we're going to do is I'm going to apply the material directly on it, like we did. So bring this up. Here it is. It's this one there, right? Select that, eyeball, assign. So this should be okay because it has, we can inspect it so you can see actually this is helpful. I'm going to go to modeling in a way. UV editor, and we're going to see like we had before, the front is the same. This one's actually cleaner. It has a proper cut. If we look carefully, you're going to see I cut correctly. So this is better. The other one was just a work in progress. And then you're going to have the light map that Unreal put in there because it's a static mesh. And then you're going to see that it has the default wraparound, which I left there in case someone wants to bring in their own sclera texture. So imagine you don't like that I've made it so that it's a flat color. You want to have some veins in the eye, in the white part of the eye. You can do that. You can change the material, just adjust the material so that it brings in your material and uses UV channel, the second channel. And that's it. So that's what I did here. So now to scale this so that it's the correct one, first I'm going to scale it by eye, and I know I'm already having an allergic reaction. I just want to see what the value is that I'm aiming for here. So if I go over here, I'm just trying to find, so of course it is, I see it, it's a 0.1. Of course it's 10 times too big. Okay, so no worries here. So what I'm going to do now is I'm going to get rid of the scaling. Right? We don't want to do that. No scaling ever. So what we're going to do is another method where I'm going to right click onto vertices. And I'm going to select all vertices. I'm going to go to scale. And I forget how do I get it down? It doesn't matter. I'll scale this here 0.1, 0.1, 0.1, and press enter. Boom. What that's doing, even though it's technically a scale, it's not really a scale. The gizmo that is a scale for scaling will change the position of the vertices. So now if I go back to translation and get out of sub mode, the object's going to be up there. I'm going to see it's got to be down. It has to be about here. So that's -9. Okay. And so what we're going to do is then we're going to set this so that it's at 0. And at this point, I should be able to freeze this object and delete its history and then apply the skin that we did before. So all we're going to do is, and this is going to take like 5 minutes, but this is useful for us to see how to fix these problems, because this is one of those things that I've been told, and I think I feel strongly is that this is important because you can actually see how I problem solve things. Okay, so now this object, I'm going to freeze it using, so I can freeze its rotation, and I'm also going to freeze its translation because it's got a -9. I'm going to go apply. Everything's zeroed out, right? And now I can move this guy over. What was it? 1.3. Yes. And now if I duplicate this and I go -1.3, done. Okay, so we're going to grab these two guys. We're going to delete them. And now I'm going to make, I'm going to add those skins. We could maybe save ourselves some time and combine the two. I don't trust it. Okay, so I'm just going to do it manually for each one. So I'm going to select the skeleton that I want, and then this. And then go, let's see if we can save some time by doing the skin, but this time, don't do the whole hierarchy, just do the selected joint. And go apply. So now if we look at our animation, it should be just fine. It's not doing any weird warping or anything like that. Okay, good. And now this guy is going to get the same treatment. This, select the skeleton first and then the mesh. And we're going to do the exact same thing. Apply. Now we should have everything fixed. Our selection set is not going to be happy. I think if I'm not mistaken, you just do this. Yeah. So now I can just right click this, select set members, file, export. Where am I gone? export select this selection. And this is going to be SKM eyeballs, right? It's got the correct time. Yes, I believe so. It's SKM eyeballs. Okay. So now if I go back to Unreal and I go back to our example here and I go for the skeletal mesh, I go re-import. Boom, everything's fixed now. So I think it was worth doing. We're going to see that the eyes are quite nice. Even if we have them scaled 5 times bigger, it's okay, because this scaling is not something that's going to cause us any trouble inside of Unreal when we scale the entire when we scale the entire actor. This is called an actor, and that should be fine. However, if this was a skeletal mesh that was being put into a blueprint where there's IK, I would strongly suggest avoiding any scaling, even at that level, and redo the skin on a mesh that's bigger and change the skeleton so that's bigger. I actually have a video that explains step-by-step how to do that. So if you have a character in Maya that you've been using and you want to use it in Unreal and you're bringing it into a blueprint, I've got tools there that it will help you with this sort of thing. So now if I look at the animation over here, everything should be just fine now. Okay, with a nice little reflection. Let me change the light so we can see that nice effect. Remember, this ball is round. The sphere is round, and it doesn't have that cornea kind of like shape that pops out. But when we move the light across it, it gives us that impression that it is. One of the reasons why I do that, and you might say, well, that's not physically accurate. The reason why I do that is because if you have eyelids that go on top of it, your cornea is not going to go through the eyelids with this method. And when you're looking at the light, it gives you the impression that it's doing it correctly. So what's more important? So from my perspective, I think having a proper, here, I'll just press play while I'm chatting here. Our animation's just fine. We updated to the mesh and life is good. Let me see if I can, F, there we go. The object's much too small. So anyways, but we get the idea. So now we have everything working properly, and we have exactly what we needed for what we set out to do. And we have our refraction. We can change the color of the eye very easily. We can export our animation without any fear. Life is good. So that's it in total. We've covered a lot of ground. I know it's a long video, but we covered a lot of ground, and we saw a lot of obstacles again that we managed to get through. And that's important in the process of learning this kind of stuff, and just dealing with a big part of rigging is dealing with problems and figuring out how to get things to work the way you want it to do, and simplifying things as much as possible so that the animator has as much upfront in their software that they're using, so that they can animate without having to guess what it looks like and not have to press a button later and render everything out and go, oh, it's not at all what I thought it was going to be. Everything is always got to be real time, and or at least enough information has to be there for them to be able to animate. If we were to animate in Unreal, we'd be able to do all kinds of changes to the material, and that's just fine. So that's it. That's it for this video. I hope you enjoyed it.